and do make a note of the date. We'll be sending more information to you in due course. Well, thank you for your support in watching, and I hope you're reading too. This is the magazine that we produce every month. Many of you are subscribers. If you're not already or you don't receive it regularly, please do visit cemtech.com/subscribe, and you'll find out how to order your copy of your subscription. It's packed full of useful information, in-depth case studies, country reports, really keeping track of all the developments going on in our industry, and hopefully a great resource for you. It comes with the Cement Operations Handbook, and now in its 7th edition, really a very popular handbook used by so many companies around the world to help train their workforce, and a very concise guide to managing your cement plant, and it's full of useful references. So that's free with the ICR subscription. Take a look online for more details. So on to the topic of the day, the digital plant and Industry 4.0 technology. As I mentioned earlier, it's really been a standout subject for us this year, and it's been building over 3 or 4 years, but I think now everyone knows what it is, and are getting stuck into adopting this technology in their own environments. Here's our agenda for the day. As I said, the opportunity to automate and optimize almost all areas of the cement plant is in front of us now. The technology is often proven, although it's developing very rapidly, as we'll hear today. We're going to hear some examples of how it can support your cement plant dispatch and distribution. With Inform from Germany, we're going to hear from Optimative in Spain about a fully AI automated operation in cement plants, taking us into the future, and some vision for where this can take us ultimately as an industry. But we're going to start with a presentation with Kluber and Dalog, who are going to talk about optimizing girth gear reliability and TCO, total cost of ownership, with condition monitoring and lubricant optimization. I'm going to allow Marcus, if you'd like to start sharing your slides. Marcus Burbach is the global head of cement at Kluber Lubrication. Prior to this role, he worked as head of marketing and business development in North America for Kluber in the US, where he was responsible for marketing, application engineering, technical services, and product management for the Kluber Lubrication Summit brands. Marcus is joined by Christoph Muschauek, operations manager at Dalog, based in Germany. The company provides online condition monitoring for predictive and proactive maintenance across multiple industrial sectors, with class-leading products in the cement sector. And Christoph graduated in industrial engineering at the Universidad de los Andes in Bogotá before starting his career at Dalog. In his current position at Dalog, his role is to help the cement industry to identify and eliminate weak points in their predictive maintenance strategies. So I'm going to hand over the presentation duties to Marcus and Christoph. I'll just remind everyone that as well as the chat section, there's a really important button, the Q&A button. It's there for you to ask questions to whichever speaker or panelist you'd like to. Please use it, and we can field the questions at the end of this presentation. So, Marcus and Christoph, over to you.
Great. Thanks very much, Thomas. Can you hear me well?
Yeah, that's perfect. Thank you.
Wonderful. Thank you. Welcome, everybody, and thank you for joining today's webinar about optimizing reliability and total cost of ownership of girth gears. My name is Marcus Burbach. I'm responsible for the global cement business activities at Kluber Lubrication, and I'm here today with Christoph Muschauek from Dalog. Kluber and Dalog are very different companies, actually, and we started working together about 1.5 years ago when we were involved in the same customer projects, but actually independently. And we noticed that we're really trying to help the customers to achieve the same goal, just with very different methods. In the case of Darlog, it is online condition monitoring. In the case of Klüber, it is lubrication. But it was always about improving reliability, improving total cost of ownership. But we used different methodologies as different solutions. And we also supported the customer in different stages of the life cycle of the equipment. And based on this realization, we recognized that if we combine our solutions, we can actually provide the customer with additional benefits that they cannot get from each of the individual solutions in isolation. That's what triggered our collaboration. We are now working in various areas where the reduction of friction and wear by means of lubrication and online condition monitoring can make a difference to the reliability of cement plants or the equipment in the cement plants. What we will focus on today is about girth gears, and we're going to look into this a bit more in detail. Before we start off, we want to give you a very brief introduction of our companies for those of you who may not be familiar with us. Christoph, if you want to speak briefly about Darlog.
Yeah, sure. Thanks, Markus. Darlog is providing industry-specific condition monitoring solutions for more than 20 years. We have customers in more than 60 countries, and today our diagnostic center is providing machine health assessment for hundreds of cement plants with hundreds of ball mills, kilns, roll presses, VRMs, and support equipment such as bucket elevators, pans, and other transport equipment, for example. Yeah, so far so much about Darlog. Markus, what can you say about Klüber?
So Klüber is a lubricant manufacturer, and we are focused on high-performance lubricants that can improve reliability, energy efficiency, and total cost of ownership. We are present with own subsidiaries in about 35 countries across the globe, and in countries where we don't have own subsidiaries, we have more than 100 channel partners that serve our customers. Where we have our own presence, we also have own sales and service teams on site that work directly with the cement plants. We have a total workforce of more than 2,300 employees across the globe, and out of those we have more than 45 dedicated cement industry experts, many of them with decades of experience in the lubricant and or the cement industry. As I just said, Darlog and Klüber collaborate in different areas. The one we're going to focus on today is the girth gears. You can see here an open gear or a girth gear as we find them on mills or kilns, and this is where our solution can provide cement plants additional or increased reliability over traditional lubrication solutions or over traditional online condition monitoring solutions. And before we talk about the problems we solve, just want to kind of recap what challenges cement plants typically have on those girth gears to make it easier to understand how our solution actually helps to overcome them. So first and foremost, the biggest challenge that we see is that these girth gears are exposed to enormous stress. There is misalignment of kilns, there are overloads of the kilns or the mills, contamination of the lubricant that is on these gears. There are frequent starts, exposing them to a lot of stress, and that creates a lot of wear, stress, and makes them prone to failure. Now, to prevent that failure, these girth gears are regularly inspected. But the challenge with these inspections is that, first of all, they're completely manual. Some of the parameters that you need to inspect, you can only read or measure while the equipment is in operation. And then other parameters that you need to check, you can only check while it is stopped. So you can never really get a complete picture at the same time. You also often have the challenge that the gear flanks of these open gears cannot actually be visually inspected because they are covered by a black lubricant. So you can never really assess the health of these gear flanks and never really see if there is wear or damage. There is sometimes limited or no documentation of these inspections. Sometimes they are done offline. There is no documentation that is on a cloud or on a SharePoint or anything where people can look up the reports. And there is also very difficult to inspect those spray systems that apply the lubricant onto those girth gears. Oftentimes they are pretty difficult to access, or it actually needs quite a bit of manual dismantling to properly check them. Another challenge that cement operators often face is lubricant starvation, so that no lubricant actually gets on those girth gears, and as a result of that, you face severe damage, which often happens within a few minutes of no lubricant application. And that happens because these spray systems can fail. Often there's also no visual inspection of these gear flanks possible simply because this black lubricant that is often used blocks it and makes it intransparent. We also notice that whilst there are state-of-the-art lubricants out there, transparent lubricants that actually allow to visually inspect those gear flanks and that provide a much better wear protection, these lubricants are often not utilized, either because there's no awareness about the benefits they can bring with regards to wear protection, or because the slightly higher cost for those lubricants make them look more expensive, whereas actually they provide a much better TCO compared to those black lubricants that are most widely spread in the market. And these challenges result in probably the biggest challenge, that if girth gears fail, there's a lead time of 6 to 12 months to replace a girth gear, and the capex for a girth gear pinion combination ranges somewhere between 100,000 and 1 million euros. So if it breaks, it's actually a huge risk to production, and it's a huge root cause for unplanned downtime, because it just takes so long to get a new piece of equipment installed. Now, these are the challenges we're trying to solve, and Christoph will talk you through a little bit how exactly we work together.
Yes. Well, it all starts on, here we will talk about the reliability of girth gears, and it all starts with preventive measures. So the foundation is a good lubricant, ideally a transparent lubricant, as mentioned, also helping the visual inspection. Then the next point is the vibration, spot measurement of vibration, gear temperatures, and visual gear inspection, all necessary to provide the foundation for the reliability of the girth gears. Now, what is happening is what happens in between these time intervals. So here we have a situation that we are more or less blind at the moment on the girth gear. So that's why we implement predictive measures. Spray system. Also, we look at the spray system. Of course, an important measure, because that can easily lead to starvation. A failed spray system can easily lead to starvation and then cause major damage on the girth gear. So what we have is vibration online, not only spot measurements and not only like average vibration values. Here we really do a signal processing to analyze the condition separately of girth gear, of pinion, and the bearings. Then as a next step, we have a monitoring system for the spray system online. We have a run out measurement online to see the pitch and issues, for example, at the girth gear and the pinion. And we also check the gear temperatures online. So now you have these measures in place, but what can we do about it? What's the how to interpret it? And this comes with the next step, with prescriptive maintenance. We give you actionable insights, trigger-based corrective. So actionable insights means when there's an increase and a change in the signal, we check, we tell you what is the root cause, where do you have to look at, and what actions are necessary to take. And in case it is necessary to do corrective actions, Klüber is committed to go on site based on these triggers and support any corrective actions on site. If an immediate action is necessary, for example, we know there's a problem with the spray system And if we not shut down the machine immediately, we will have severe damage on the gears. Then we can also trigger, for example, because we're connected via field bus to the control system, we can trigger, for example, also a mill stop. In case of any damage on the girth gear, Klüber can support the reconditioning of the girth gear with their products. And on the other side, continuously, we are supporting a safe lubricant upgrade. So first, the change and also the optimization of the lubricant is always monitored with the parameters such as temperature or vibration. And we also monitor corrective actions. So if we change something in the setup, this is also monitored then in our parameters and will give them back as a feedback to the plant. On the next slide, we see then how the condition monitoring side is looking like. You can see the girth gear and the pinion. You can see the sensors that we have in our dashboard, how you will be able to see the data. And you can see it's a multi-sensorial condition monitoring system, including the gear flank temperatures, the web dashboard, and the remote support from Darlog and Klüber. And what are we monitoring? We monitor the girth gear in regards of wear, cracks, run out, contact pattern, lubrication, the pinion, the support bearings, and importantly also the spade system in regards of intervals, duration, or clogging, for example, which is a common root cause. What do we want to avoid? We have here then two pictures coming up of failures. Exactly here, for example, on this left side, the support bearings over lubrication causing then also failures. Yeah, it's a waste of money, and also it's not good for the components. And on the other side, you can see the pitting wear on the girth gears. It's also something that we need to avoid. So much about the condition monitoring side. Markus, maybe you can tell a little bit about what Klüber and the lubrication is providing for the girth gear.
Right. So as Christoph explained, we're measuring a lot of values with the sensors that basically take these manual measurements to continuous measurements to make sure there's a 24/7 monitoring. And as a result of that enables Klüber to come on site and to support your teams right at the time when an issue occurs, and not just at certain set dates of inspections that happen every few months. But of course, we don't just want to measure problems and then come on site. In the first place, we really want to avoid those problems, because now you start measuring all these data, and what you really don't want is to get constant alerts and constant notifications that things are going wrong. So what we recommend is a switch from traditional plaque, asphaltic or graphite-based lubricants to a transparent, high viscous, state-of-the-art lubrication technology. And the benefits this will give the cement plant is, first of all, visual inspection will become possible on those girth gears. That makes it possible to see damage or wear on these girth gears. First of all, during operation, when you have no chance to clean off the gear. And also it will give you that picture across the whole gear and not just at a certain area where you might clean it off with a piece of cloth. From these lubricants, you'll also see a better wear protection, which again reduces the likelihood for failures and therefore the number of alarms that you might be getting with the sensor monitoring. And also you'll see significant cost savings. And I just want to give you an idea of what that exactly looks like. So from a lubricant consumption point of view, you'll see a drop of 30 to 50% switching from a black lubricant to a transparent lubricant. And as I said earlier, you really want to look at the total cost of ownership. These lubricants are slightly more expensive, but you will still experience a cost reduction of 10 to 20% from that volume reduction. And here on the right side, you can see a before and after picture. On the left side, you can see the gear with the black lubricant on. It's absolutely impossible to see the health of the gear flanks. If there is damage, if there is wear on a kiln that you barely shut down, you really have no possibility to check that, because there is just no time to clean off that lubricant. And also you don't get an optimal wear protection from these black lubricants. On the right side, you can see how that looks after a changeover with a transparent lubricant. It actually looks like there is no lubricant on it, but there is a lubricant on it. You just don't notice it. It's transparent. You'll get a complete picture of the gear flanks. In that case, they look beautiful, no damage. You'll also get a 3 to 7 times higher wear protection. And very important, because you're not using these tacky, solid containing lubricants, you'll also see less clogging of these spray systems, which often fail because of that clogging, and then have that lubricant starvation that causes that damage and that causes these alarms. So you'll have cost reductions and 100% more transparency on these gears. To sum up all these benefits that we just highlighted, just want to give it to you on a glance again. So what you'll get from that joint solution that Darlog and Klüber offers is a continuous automated real-time monitoring of most of the parameters that you would usually measure during a manual inspection. And on top of that, you get various additional parameters that are not measured during such inspections. That allows you to immediately detect vibrations, overloads, lubricant starvation, and spray system failures. And if you like to do that, they will trigger an alarm. And if you like to do that, even shut down the equipment if you want that. So that will really take you to a new level of preventive maintenance, which is also enabled by the visual inspection of these girth gears, right? You can look at them at any point in time, you can see the health, and you don't have to wait until that gear actually breaks down because of a damage that was undetected and covered by that black lubricant. That will increase your reliability, and also that reliability will be increased because our engineers will come on site when we see irregularities in the measured data from the Darlog dashboard, right? Our experts and the Darlog experts look at these dashboards together, make recommendations, and if we see there is a certain irregularity, we should be on site. We come at the time when that happens, and it will not just happen when somebody from the plant detects the problem by accident, or when somebody from us comes for the next manual inspection. You'll also get higher gear protection. As a result of that, you'll get a longer gear lifetime, and you'll face reduction of the lubricant consumption by 40 to 50% by switching to a high-performance transparent lubricant. Your maintenance teams will experience less work. They have to do less inspections. They have to do less documentation. They have to do less gear cleaning to make those inspections. And they also have to do less work on cleaning or even fixing broken spray systems, because they will not experience that clogging anymore. So that will give you peace of mind that inspections are not forgotten, and also that they are correctly performed and also documented. And last but not least, working with us together will basically minimize the coordination effort for your plant. Darlog and Klüber are experienced in working together. We work as one team. So if you decide to go for such a solution, we will coordinate internally. There is very, very limited work for you left to be done, and definitely no coordination work for the plant left to be done to integrate those two solutions. And Christoph, if you can talk us through the implementation process, just to make it a bit more specific how we approach such a implementation, such a changeover.
Yeah, I'd be happy to. Let's see how to boost the availability and efficiency in some easy steps. So the first one, we look when we start with an on-site inspection of the open gear. We determine the condition and whether reconditioning procedure is advisable before we could start with the lubricant changeover. And the next step, and almost simultaneously after this inspection, we will start with the engineering and the supply of Darlog sensor technology, so it's tailor-made according to your needs and your design of the girth gear. And then we would do the changeover to the transparent Klüber lubricant. We would also check if a cleaning or running in lubricant is necessary. And then from my point of view, then the magic begins, because here now then the synergies are really kicking in. Together then with the on-site support from Klüber, we can then put the parameters and set thresholds for the alarm levels, for temperature, for the spray system, and also already compare then also the pre-Klüber oil condition with the after the change. Then in the next step, we can do the controlled optimization of the lubricant consumption. So of course the idea is to be as efficient with the consumption as possible, and that can only be done, or is recommended to be done, of course, with continuous monitoring of the parameters. So we go down with the consumption, we check the temperatures, we check the vibration, and the impact that the new consumption and the new spraying arrangement has to the girth gear condition. And in the end, what you will have continuously after this first period is an online monitoring with event-triggered on-site expert inspection. So if we see anything, our diagnostic center here in Darlok, Germany, we will remotely support you. The same goes for Klüber. And in case of any strong indication, the local Klüber experts will also go on site and inspect the girth gear and support any corrective actions that might be necessary on the girth gear. So this is basically the setup. On the next slide, just how to get started in reality. The easiest step is talk to us. Marcus and I, we are there to discuss the situation of your girth gear. And we would then, this would be followed up by an on-site inspection of the girth gear and the gear guard housing. And then we would work on a joint proposal and implementation schedule, followed by the actual implementation. So I hope you enjoyed the presentation, and the point we made clear one point. What we see is that the whole of the solution is really a lot more than the single pieces that Darlok and Klüber can provide individually to provide you a better solution and better lifetime for your girth gear.
Thank you very much, Marcus and Christoph. That was a great presentation, fascinating, and it seems like a perfect combination of capabilities from both your sides there, offering the diagnostics and then the follow-up and triggering these kind of inspections when required. It really also the switch to the transparent lubricant has some great attractive qualities. Is that how new is the transparent lubricant? Is that a fairly recent development, or is that just something that you're trying to promote now because it has such obvious benefits?
Yeah, that's a great question. Actually, it's 30 years old technology, but the technology we're trying to replace by that is 6 years old, right? So I think probably a lot of people will agree that because of the 24/7 production process, the cement industry is pretty conservative and hesitant to make changes. And I think this is exactly where our solution fits in, that a lot of cement plants see the benefits of those transparent lubricants, but yet are hesitant to make the change, to reduce the lubricant consumption, because there's still a perception that, you know, the more you use, the better, which is really not the case. And with monitoring it, continuously with the sensors, can give customers really that peace of mind that they are not just doing the right thing, but they can really see with the sensor monitoring that nothing kind of deteriorates. Actually, quite the contrary. You'll improve your performance, and it's absolutely safe to make this change. It's absolutely safe to bring down the consumption of the lubricant. And of course, on top of that, you'll save money, and you'll see the condition of the girth gears. But we still see that a majority of the market still uses black lubricants actually.
Yeah, but I guess with the online monitoring, then you have that comfort, a little bit more security, knowing that there's something there just checking and alerting you to any problems. With the online monitoring, Christoph, how for plants that are not equipped yet with a Dalog system, for example, how many sensors? What's the investment required to, let's say, set up the sensors and a system such as yours?
Yeah, it depends. Now, when we talk about the girth gear, there we have around about 8 to 10 sensors, I would say. In general, when there's the plant has no condition monitoring, we would talk to the plant and we would make, together with the plant, assess the criticality, where they have in the past experienced problems, where they had really issues, and tackle these first. Typically, this is like starting with the big mill drives, for example, and then the kiln itself together with the girth gear, always together with the girth gear if it has one, and then slowly cascading down to smaller equipment such as these support equipment from bucket elevators, for example.
So in a plant, I mean, what are the areas of application are very broad then, and you're not just servicing kilns, you're doing the whole process. Yeah.
Yes, that's correct. Yeah.
There's a question asking, how can you monitor cracks on the girth gears and pinions? Can you talk around that a little bit?
Yeah. So this is done basically mainly with the vibration. We can distinguish from the kinematic frequencies and from the signal pattern, we can distinguish, for example, wear situations to single cracks. We will see it on the girth gear typically. Of course, when you have one gear is cracked, then you will see once per revolution of the girth gear, you will see this crack when the gear meshes. And this we can assess and identify. And here, the goal is really also for the girth gear, it's maybe not so critical, but especially for closed gearboxes, the goal is always to avoid that a part of the gear tooth is cracking off and falls into the gearbox. And that we are also able to detect with these kind of signals, because we can then detect changes of the stiffness of the material that we can detect, and then we can even act and, for example, take out the tooth part in a controlled manner instead of just having it cracking off within the gearbox.
Okay. Another question is, how do you guarantee that the online measurements are correct and not affected by build-up and lubricants contaminated by solid particles? And a second part of the question is, do you have a digital twin philosophy?
Yes, that's why we rely on several parameters as well. We have the control also from the gear temperatures that we control. We also check for the run out condition, for example, of the girth gear. So that is then all in there. And of course, in the end, we cannot give 100%. Sometimes we can point out that there is a change in the signal pattern. And in that case, this is the advantage of working closely with Klüber or also then the plant team that can then go on site and do the inspection of the girth gear and verify our findings.
And in terms of the alarms that are triggered, how sensitive is it? I mean, are these alarms getting triggered constantly, or do you calibrate it in a certain way for each plant to find the right level? How does that work?
Yeah, this is more of the most important parts of this is to have the minimal amount of alarms necessary. Because of course, if you get too many alarms, and that's often happening for the operator, you get so many information, so many alarms, they're just getting ignored. So that's why only when it is really critical, then we will trigger an alarm, and then the person should also know that it is time to take some corrective actions.
Okay. There's a few comments and questions also in the chat. Just a quick one for Marcus. Where is the fluid lubrication added on the girth ring or the pinion?
So there are different types of lubrication. There are spray systems, there are bath lubrications. We do typically lubricate on, well, it depends a little bit on the setting, but typically it goes on the girth gear.
Okay. There's a few comments. Some say it makes sense for companies like yours to join forces and provide a better solution. Well done, and very interesting. On machines so sensitive to misalignment, continuous monitoring and on-site verification is very important. I think we agree with that. But an excellent presentation. There are a few more questions there, but we've run out of time. So thank you very much, Marcus and Christoph. Excellent presentation, really practical and useful. I wish you luck with this new initiative. It makes a lot of sense. And I hope you're very successful with it. Thank you very much.
Yeah, thank you, Thomas. I would really like to encourage everyone who has still pending questions. You have our email and also our LinkedIn. You can write us on any medium, call us. We are very happy to support you and answer any of your questions. Thank you, Thomas.
Thank you very much.
To that, if you allow me. This is the solution we presented today, but as we said earlier, we're keen to develop additional solutions wherever friction reduction, wear reduction with lubricant and online condition monitoring can come together. So if you have ideas, we're very open for research projects and trials. Just get in touch and discuss with us. Thank you.
Excellent. Okay, and those slides will be distributed and have all the contact details on them. So look out for the email after the webinar. Okay, thank you very much. So we're going to get on to our next presentation, which is entitled Towards Fully AI Automated Operation in Cement Plants, State of the Art and Vision. And with us today, we have Javier Garcia Sedano from Optimative in Spain. Javier has a master's degree in physics, specializing in electronics and automation from the University of the Basque Country. His areas of work and expertise include industrial artificial intelligence, machine learning and optimization algorithms, energy and resource efficiency in industrial processes, advanced industrial data mining and data analytics, and the list goes on. So very qualified to speak with us today. If you'd like to share your slides, Javier. Javier has more than 30 years of experience in these fields. He founded Optimative Group in 2008 and since then has created a track record of successful and innovative artificial intelligence applications. And we're going to hear about some of those right now.
Thank you, Thomas. Good afternoon, everyone. And wish you all good health for these days. Okay, can you see my presentation?
Yeah, they're up there. Great.
Good, excellent. So Optimative, as the name says, we are specialists in optimization. And we do this by means of artificial intelligence. Our purpose is to achieve the massive adoption of artificial intelligence in operations in the cement industry to help cement industry become more efficient and sustainable. Let's see how, and I will share with you the state of the art and our vision for making this a reality. So most of you are familiar with problems that happen at the level of operation in cement plants, and including the loss of operating experience when older operators retire, which have the knowledge of having been working there during years, suffering stability, quality problems, sometimes for unknown reasons because of a sudden change in raw material which is not measured, whatever, struggling to increase the business margins, reduce energy costs, which is not so easy when you have to guarantee stability and quality, and also to satisfy the customer needs when production orders come, and working in a maximum production capacity and being able to produce a bit more is highly valuable and not always such easy. So those are the challenges that we are facing in cement industries right now. And the problem in control rooms is that the operators need to take decisions which are based on hundreds of variables moving all the time. And they are limited in terms of processing all that information, taking accurate decisions, and making it continuously on a minute per minute or much faster basis. So that's not possible for a human operator. That's why we propose and we install for our customers artificial intelligence systems that are connected to the control room, to the control process control system of the asset, be it a mill, a kiln, and on the basis of those data arriving all the time, it learns with machine learning technologies, artificial intelligence, it learns how the process behaves, and it is able to apply optimal set points at all times depending on changing conditions. In this way, taking the most of the process with it at every single condition of raw material, energy prices, alternative fuels, and all. So this is possible to work on premise or in the cloud and allows to achieve the optimal performance, which is the purpose. But this is a solution which is at hand of the process of the cement industry right now. So what about artificial intelligence? If we go back to 2011, artificial intelligence was like this, a small thing, only visible for some few people in the industry who were paying attention normally in research projects, something like this, but not such visible. Now, the situation in 2021 has changed completely. AI is in the focus for the whole industry, not only the cement industry, the process industry. We witness that every day. What happened is that if we look at this graph represents the evolution of the popularity of the term artificial intelligence measured by the Ngram viewer tool by Google. And I was witnessing there the AI hype in the late 80s. And then it was followed by the disappointment because of lack of experts in the field, limitations of hardware or software. So it was still early for artificial intelligence at that time. And then crossing the desert. But then something happened in the after 2010. The Industry 4.0 was coined in Germany, and TensorFlow was released by Google. And that changed completely the scenario. Now we are living again a golden age for AI, and it has become extremely popular and desired. So when looking at when artificial intelligence can be applied and how it can be applied for helping operations in cement factories, we basically are looking at the operation layer, also at the advanced control layer, which are very much related. So real-time optimization, as we can see in this graph, which depicts the hierarchy of automation systems in practically, which is common to every process industry. Starting from in the bottom, sensors, actuators, then the basic control loops based mostly in PID, the distributed control system, and advanced control layer can be there or cannot be there. Sometimes you find it, sometimes you don't. In the end, the RTO, the real-time optimizer, can work on top of the advanced control layer if it's there, or on top of the DCS and basic control loops if they are there. In fact, an AI-based real-time optimizer can take over part of all of the roles of the advanced process control. So this is the good thing of artificial intelligence. And there are three major technology trends when looking at real-time optimization. In the cement industry, we have the linear matrix-based approach, in which linear models are used mostly for the advanced process control. There is another trend which is making use of fuzzy rules, which are these condition action rules, and they are not so much technically speaking optimization. They are expert system, but they provide advanced control, but not exactly optimization. Then we have the AI-based modeling approach, which assumes that highly nonlinear models can be learned on the basis of process data, which is there available. So the artificial intelligence approach for learning models or for the optimization of operations has three main advantages, which are they are able to learn highly nonlinear relations, which are there because reality is nonlinear in the complex, sophisticated processes. So for optimization is needed to be aware of the nonlinearity of the process. Then the AI models can be set up easily only on the basis of data, and data are available, and those models remain continuously updated thanks to the built-in machine learning capabilities. To compare the linear traditional approach with respect to the artificial intelligence approach, on the left we have an example simplified of how linear approach works for optimization. Is that the KPI to optimize is related linearly to the set points, and the constraints are also linear. So the solution for optimization can only be like depicted here in the corner of the search space, but this is only an approximation. The reality is more complex than that. And on the right, reality can be learned with all its sophistication by means of an artificial intelligence and machine learning based system. And also the constraints are nonlinear, like this one that we can see here, which is obtained from a real vertical raw mill. This is the vibration constraint depicted, represented graphically, and the nonlinearity of constraints also allows to obtain more precise optimal points of operation. There is a big trend right now as well, which is enabling process engineers, which are part of the staff, a major part of the staff of big corporations and small corporations and manufacturers of cement, process engineers to become able to build models, to train models on the basis of data and assemble and create their own optimization solutions. The market is demanding more and more this kind of solution, this kind of deployment of artificial intelligence, and this is becoming possible because of and thanks to design tools that the ones that we have developed in Optimative. So we are talking of availability of no-code design tools, enabling to create, to train models, and enabling as well to assemble models and create artificial intelligence solutions for optimization. So in this case, for example, how it works, using the design tool, which is the data analysis and modeling tool, the design tool to configure and test a solution. Then the solution is executed by means of the real-time optimization tool. And the real-time optimization tool works automatically connected to the process control coming from the control system and fully automated. No need for human intervention. So that's the concept of fully automated AI-enabled operation. Operators are there because the operators have to respond to abnormal situations, startups, shutdowns, and they have also the possibility of changing things that changing the production, which are what are the priorities if they want to optimize for production or for energy at a certain time for some reason, what are the specifications in terms of quality that they want the optimizer to respect, and what are the ranges for the certain variables, the controlled variables that they want to be respected. So this remains at hands of the operators. And in Optimative, we have solved this by means of a suite of software tools, which is composed by the design tool Optibat Studio. And we call it the AI CAD tool for process engineers because it allows to load data, to train models on the basis of that data, to assemble models in a graphical way to create, to build a solution, to test the solution and simulate how it would work. And then when we are happy with the result, then save it in a project and be executed. Be executed by the second tool of the suite of the software tool set, which is the Optibat RTO, which is the execution tool connected in real time to the process control from the process control system and assisting the operation, normally in closed loop and fully automated, but also possibility of working in open loop, assisting the operators is there. As well, the mixture of open and closed loop is a possibility. We recommend fully closed loop because it ensures that operators are released for their most value-adding tasks, and at the same time ensures maximum efficiency and maximum profitability of the system. The result is a running system that can read and receives the data, the process data, can also integrate meteorological data from external sources when needed, can also integrate energy and fuel prices from the internet and external sources as well, and of course the quality data coming from QES or whatever quality system or ERP. So all that information together feeding the system in real time, and the system generating the optimal settings, the optimal set points, and feeding them back to the process. So this has applications in all the assets of a cement factory, but those who are giving the highest return on investment are the kiln, the raw mills, and the finishing mills. And we will see specifically what can be achieved with with each of them. So, for example, with the kiln, it is possible to achieve results in terms of throughput, 3 to 6% of increase. The energy can be reduced in 2 to 5% savings, and the free line, for example, can be kept into the allowed desired ranges in more than 90% of the samples. In the case of the finishing mills, results in this kind of full automation with AI can reach 5 to 10% of increased throughput, savings in energy of 3 to 10%, and quality improvements, blade passing, achieving the 90% or even 100% of cases in range, in the desired range. And in the vertical raw mill, throughput increase 2 to 9%, energy 5 to 10% savings, and fineness as well can be optimized. And the three of them at the same time. So this is the magic of artificial intelligence, taking the most, looking at every single variable, taking into account all the factors or the constraints, and making the best for the cement plant. We have an example for best practice in this sense. So one of our customers, Titan Cement in Titan, America, they have 14 factories, and in the Pensuco cement plant, they have already installed our technology, artificial intelligence, running in closed loop, optimizing the mill, the raw mill, the kiln, and the three finishing mills in real time, continuously, with very, very good results, excellent results. And this is being repeated in further applications, further plants. So best practices are there. Right now is the time in which artificial intelligence demonstrates and has demonstrated that this is a reality, achievable and implementable. Some few words about when coming to AI, what's that of the war, IT, OT war, information technologies versus operation technologies. Is this that fight reality? In my opinion, the ITs have always been there, incorporating the operations research, cybersecurity, computing, sensors, databases, and more recently interested Internet of Things, artificial intelligence, cloud computing, data science, but always a long time. We have seen that operational technologies, which are those that are in the field, like the CNC electronics, the physics, the PLC technology, measurement sensors, field buses, they have been incorporating ITs continuously, ever, from the very beginning. Only the question is that operational technologies take their time, because the ultimate responsible for moving a valve has to be a person with a knowledge, and that belongs to the realm of operational technologies. the ITs, when they are incorporated successively to the OT, they sometimes incorporate their own names, like the IIoT, industrial AI, and so on, advanced process control when it came to the control stuff. In our consideration, artificial intelligence will have to be genuine to really provide the value to the industry that really the industry deserves. And we are talking of easy to maintain, because we don't want cumbersome solutions, difficult to maintain, and creating more problems than solutions. Self-learning and self-adaptive, because all the time the conditions in cement plants are changing. So there is a need of continuous adaptation and evolution of the performance of the asset. Ubiquitous, because nowadays the computing resource can be here next to the plant or can be in the cloud, taking advantage of the highest and the most powerful computing resources. They are there. You can hire them by means of any of the cloud vendors. So that's a resource worth to be considered, worth to be taken into account. It has to be easy to install. It has to be precise. And we are talking of the non-linearities, the complexity, and last but not least, it has to be meaningful, able to explain. We don't want more black boxes. And artificial intelligence cannot be a black box. It has to be a white box, able to disclose what's inside, what it has learned, and show it to the process engineers who are the knowledge holders in the cement industry. And we are talking of engineering knowledge. The process engineers have a word to say in this process of adopting AI in the industry, because in the end, when you are training a model, for example, some of you will be familiar, cause and effect relations have to be taken into account, because otherwise blind application of data science, of data mining, can yield absurd results and useless results. So the engineering knowledge in terms of implementing the right constraints, applying to the right variables, which are the degrees of freedom, everything has to be used, has to be effectively used. But we are talking that the process engineer is now accompanied more and more by another kind of professional when talking to AI, is the data scientist. And many of you will be familiar with this term because they are more and more present there in the cement industry. We are seeing them and we are meeting them every day, but they have completely different mindsets. And there is here a knowledge, let's say, a gap between both of them. The data scientist, he thinks in graphs, in scatter plots, in the classification trees, and this kind of stuff, while the language of the process engineers is the process flow diagrams, the PNIDs, and the cause and effect relations between the variables. How to put this together? Okay, that's the point, and that is a point that has to be solved. And we are working for this, precisely to join the two worlds of knowledge, of the data scientist and the process engineer. What's needed to achieve the massive adoption of AI in operations in the cement industry? We are witnessing approximately less than 2% of the cement assets are right now conducted or optimized or managed by means of AI. So what's needed to achieve really a larger scale deployment? In our opinion, there is a need for success stories. It's a reality. When you are looking around and the other producers have implemented AI, okay, then you want to mimic them and you want to apply the same successful case. That's clear. So more and more success stories will be needed and will be there. Another is the modernization of IT infrastructures and data hubs, historians, and also, well, it's not to be forgotten, the quality of the product, the quality measurement is something that we find every day. The better the quality measurement in a cement plant, the better the possibilities of applying artificial intelligence at full scale. And I'm talking if you are in charge of cement factories, improving the quality sampling, making it lower than 1 hour helps a lot. Having precise calculation, having automatization in those sampling of the quality is critical and helps a lot to implement AI. And also the knowledge representation and achieving standards for sharing and reusing the knowledge of optimization, and ontologies and semantic web technologies will have a word to say in this specific field. What solutions are there and enabling technologies? Deep learning is helping a lot. All the stuff that you can read in the literature, the knowledge representation standards to help share and reuse the knowledge that you are obtaining and you are installing. And also the cloud and edge computing is helping a lot because of more resources of computing, because of having the data available in the cloud, having there to in order to easier access, management of the data and information, and all the value-added applications that the cloud is bringing. And we believe in a future cyber-physical cement industry in which a cloud system will be hosting applications, will be hosting data. And we have to take into account that when talking of operation, not large amounts of data, it's not needed to share thousands of variables, but in some cases, good solutions can be provided with the exchange of the key variables of the plant. We are talking of some few hundreds of variables. So it's perfectly possible to have a cloud-based data infrastructure with fast responses, non-mission critical, and communicating the machines, the artificial intelligence systems, and enabling as well to have their digital twins, simulators that provide value and better applications and faster deployments for the artificial intelligence system, which is very, very much complementary. But all this supported and backed by strong industrial knowledge and standards for representation. So showing that we are serious in talking about the cloud, we are there in the Azure, Microsoft's Azure Marketplace, and you can find our solutions, the Optivat Studio and the Optivat Real-Time Optimizer for the ball mills, the cement kiln, and the vertical roll mill there in the marketplace. And just some few words to say that Optimative was founded in 2008. We are already in our 13th year of application and practice, that we are in the cement industry since 2014 with patented technology in USA, with running systems and applications in both in open loop and closed loop, and right now operating in 3 continents. Our headquarters is located in north of Spain, in the Basque Country, and this old sugar factory refurbished to host technology and engineering companies. Thank you.
Thank you very much, Javier. That was a really inspiring presentation. Lots of great feedback as well, I can see. People have really enjoyed that. You've given as well as your specific examples, you've given a really good broad sort of overview of AI and what it can do in the cement plant, and you make the point well of the different types of people involved, the plant engineers and these data scientists, and having actually to bring those two groups together is a kind of big key success factor. Just very briefly, just to clearly understand the Optivat Studio, that's something that you expect cement plants to download and start using themselves, or are you offering an off-the-shelf product that requires you to install it? Or are you saying that there's actually a blend of the two if you want?
This Optivat Studio is an off-the-shelf product that you can purchase and you can start using by yourself. In fact, some of our customers are using to create their own models and to assemble their own solutions. So this is something which is really a possibility right now. This comes with training, optional training from our side, and also we provide tutoring for the first applications to ensure that they are successfully deployed. Of course, learning how to deploy artificial intelligence is something that you can have tools, but also some training is useful and is needed in the first steps, like every science.
Very good, very good.
But the good thing is that you don't need to be an AI expert or a data scientist to use Optivat Studio, and this is the nice thing.
Yeah, okay. And in terms of getting started, what are people doing? Are they going first for the mill, or are they looking at the kiln first? Where do you start, and what's the best sort of process for getting engaged with this kind of software?
We are obtaining first expressions of interest in both cases. The vertical roll mill is something that some customers like to start and also the kiln, and we are receiving more and more first orders for the kiln because it's the most energy consuming asset, and also because it's the one that may imply more, let's say, stability and operating problems. So the one that solves more problems is optimizing the kiln.
Yeah, very clearly. In terms of I'm just going to go through some of the questions that we've had. I mean, you talked about some great results, kind of 5 to 10% range for throughput and energy reduction and quality parameters. So it's really positive. And we've also seen Fokion made a comment from Titan that he thinks these are very conservative numbers. So there are, it's clearly very effective results. Do you guarantee these improvements in terms of these energy savings or increase in production with the software?
Yeah, of course, we guarantee that improvements will be there, but it's not possible to know them in advance because it depends on the variability. When you imagine that you have raw material which is always the same, non-changing conditions, production completely always the same. So in that kind of situation, then you find an optimal point of operation and you can live, understand? So it's the level of room for optimization depends on the variability of the plant and on the initial state of the asset, understand? So it's, but what we guarantee is that we will improve it in any case.
Yeah, okay. A question here, if I've understood it correctly, how can models learn online from process data and improve if many important signals like properties of kiln feed and fuels are not available online? So I guess, yeah.
Yeah, the kiln feed is normally available in online. It's part of the control stuff of every asset. But sometimes the kind of information which might not be available is not in real time, is the raw material features and some sudden change in the hardness of the material. These kind of things can change without previous advice. But there are means of installing and solving those handicaps, and that's part of our methodology. That's part of the method that we have developed along years of work and practice with the industry. So that's all. That entering in more detail would require more time, but the point is that basically the industry deals all the time with all those kind of process of problems, which is lack of information, incomplete information, or sometimes accurate, non-accurate information. But there are ways, there are workarounds for dealing with those situations.
Fantastic. Well, thank you very much, Javier. It's been great to have you on here at cemtech. Fascinating presentation. We keep following you and look forward to seeing further developments and new applications perhaps as we go forward. So good luck and thanks very much for your presentation.
Thank you very much, and look forward to share our next achievements with you.
Very good. Great. Well, that's optimative. And now we're going to move on to our next presentation. I'm very pleased to be able to welcome back Dr. Paul Flashkamp from Inform. Paul is head of road transport for Inform Logistics Division. He holds a master's degree in international business from the University of Maastricht, Netherlands, and a PhD in systemic management from the University of Aachen in Germany. With nearly 15 years under his belt as a research and consulting professional, Paul knows a thing or two about IT and logistics. He joined Inform, a German-based software company, in 2011. In his current role as head of transport, he helps cement and ready-mix producers to drive their logistics performance. A key milestone in his career has been the rollout of a logistics optimization software project for a major international cement producer operating across several European countries. So to talk about building AI into cement supply chains, welcome, Paul.
Thank you very much, Thomas. First of all, question, can you hear me?
We can see you and we can hear you, and your presentation is ready to go.
Awesome. So thanks for the introduction and for this opportunity to speak at today's webinar on digital plant and Industry 4.0 technology. Sorry, I can't move the slide for the moment. Yeah, thanks. Speaking about 4.0, this reminds me that the fourth part of the Matrix film series will be released later this month, called Matrix Resurrections. In case you don't know the plot, the movie is set in the near future where we humans live a happy and content life without realizing that this is just a computer simulation called the Matrix. When Neo, the main character, finds out, he and some others try to break out of the Matrix. One of my favorite scenes is when Neo is offered the choice between a red pill and a blue pill by rebel leader Morpheus. The blue pill would allow Neo to continue his life inside the confined comfort of the Matrix without any fear of change. You will take the blue pill, the story ends. The red pill, in contrast, would allow him to leave the comfort zone and escape into a new world outside of the Matrix. You take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. This scene often comes to my mind when we talk to potential customers in the cement industry. They are curious to learn more about the world of digital transformation, but when asked, they often pick the blue pill and stay within their comfort zone of manual supply chain planning. In the next 20 minutes, I would like to show you how deep the rabbit hole of digital transformation goes and give you some insights into the digital wonderland. But before we enter the rabbit hole, just a few words on Inform and on what we do. Inform builds IT systems which are powered by algorithms helping our clients to make better decisions. We do that with the help of, meanwhile, over 800 employees for clients around the world in a variety of industries such as aviation, production scheduling, warehousing, and finished vehicle distribution. In the building materials industry, this means that our solution optimizes delivery schedules and truck fleets in cement, aggregates and asphalt, and ready-mix concrete. Considering various customer requirements and constraints, balancing these and producing an optimized outcome within seconds. We have been doing this in the building materials industry for quite a while now, and we are honored and very thankful that some of the big and medium-sized players have put their trust in us. 25 years ago, Redlands in France, now part of the Holcim Group, was the first company in the aggregates and ready-mix industry to use our system. 6 years later, Hanson Australia, now part of the Heidelberg Cement Group, followed suit. Both have been using algorithms, real-time information and automated decision-making to manage and optimize their fleet of trucks ever since, with amazing results. Today, dispatch teams at cement, aggregates and ready-mix producers around the world use our algorithms to ship a combined volume of over 1 million tons daily. So let's get back into the rabbit hole. Before Neo takes the red pill, he was asked by Morpheus, "Do you believe in fate?" And Neo answers, "No, because I don't like the idea that I'm not in control of my life." I'm not sure if your dispatchers and supply chain planners believe in fate, but they are at constant risk of losing control of their life. More than any other job, being a dispatcher brings a tremendous amount of pressure and stress. Each day is a challenge and each decision has the ability to positively or negatively affect and potentially complicate future decisions. This is true for tactical scheduling, where dispatchers determine the delivery schedule and fleet configuration for the following shift, but also for real-time operations. Disruptions like traffic delays, will call orders and cancellations hamper the efficiency of your operations every day. If no countermeasures are taken, the entire plan can collapse like a house of cards, with shipments running late and operational costs killing the bottom line. What's even worse, decisions taken at this stage often ignore the cost impact of the individual order truck assignment that can negatively impact revenue per truck, leaving order fulfillment as the only focus. Here's a simple example. Reducing empty mileage is an important element in finding cost reductions. Let's assume you have 2 trucks, 4 plants and 4 orders. Which dispatch assignment and route combination will offer you the lowest empty mileage? We humans are creatures of routine. We establish routines that help us carry out tasks much quicker, so we don't have to think about the task or prepare for it. In this case, choosing the closest follow-up job promises to be a pretty good routine that will deliver fairly quick results, in this case, 72 kilometers. If you sit down and take the time to calculate all potential variations, you will find a solution that offers substantially better results. In this case, you would achieve 31 kilometers instead of 72, which is a reduction of 56%. So 2 trucks and 4 plants and 4 orders is a fairly easy exercise for an experienced dispatcher. But imagine doing this for a fleet of 100 trucks and roughly 300 orders, with changing delivery times, with delays, with cancellations and with new orders, all adding complexity. If this isn't enough, the world around us is constantly changing, with new challenges and variables added to your customer base and dispatch formula every day. We have been talking about the driver shortage for the last 10 years, as it was a big problem long before the pandemic. The driver shortage will plague the road freight industry not only this year, but for many years to come. And we also have the carbon footprint and sustainability discussions, where carbon reduction in the cement industry focuses mainly on the production processes. However, fleet logistics and transportation are a very relevant source of greenhouse gases and responsible for a lot of air pollution. So some say electric trucks are a key element on the road to net zero emissions. But what impact will this have on your transport planning? This is where our algorithms come into the game. They allow transport planners to do incredibly complex, time-critical calculations with ease. What's more, algorithms can take a larger range of variables into account and can process far more data much quicker than the human mind can, thus effectively removing the human error from the dispatch formula. Today already, algorithms outperform legacy systems and human planners in both speed and quality. In case that has not convinced you yet of the power of algorithms, I invite everybody to try our little scheduling gaming app and see if you can beat our algorithms. Just scan the QR code and download the app from the App Store and have fun beating the algorithm. But let's say you buy into the narrative that algorithms are better suited for the schedule creation job. The question that we have constantly faced during our 24-year of journey in the industry always is, how do we get there? So to answer that question, the starting point for us was to realize and to remember that digital transformation is more than just an IT project. And it's not only about number crunching and software implementation. In the following, I'm going to share a few lessons that we have learned along the way. So first of all, the reason why we do this is, of course, that we want to save money. That means such a project must realize savings. So how do we do this? Firstly, our algorithms need to be able to work for you and not against you. So to do so, data quality is of paramount importance. Otherwise, the old saying applies, bullshit in, bullshit out. Data quality is, however, not only about the correctness of data, it also involves to really understand what your customer needs and putting that into the system, which means in our case, put it into the order book. And finally, have someone who's in charge actually to make sure that the data quality rules are known and followed. Secondly, in order to realize savings, all stakeholders need to agree on the common business objectives. And that involves your senior management, because we all know there's nothing worse than an argument with your senior manager about the actual objectives. So nobody comes out of such a discussion looking good. But it is not only about senior management. Classic organizational functions such as sales, production, logistics need to align on the same objectives. And as you all know, they do not align naturally. So you got to have the discussion and agree on them before you start the project. Otherwise, it's going to bite you after go live. And thirdly, in order to realize savings, you must understand and align the drivers for the savings. So one could be your haulier payment. You don't want to pay your haulers per ton delivered when the algorithms are optimizing for truck productivity. Your current cost accounting or an existing plant profit center philosophy might limit the willingness of plants to share volume and help each other. This could be a roadblock you might want to get rid of before starting the project. And sometimes clients get caught in service level or on-time delivery discussions while forgetting that there is a cost for being on time as well. Instead, a discussion about an acceptable cost for on time will get you on the right track. And while calculating your savings, don't forget to build a proper baseline to compare against. And know that sometimes things get worse before they get better. You might notice this when looking at your on-time performance and when looking at your logistics unit costs, so costs per ton kilometer. These setbacks are critical because they might lead you to turn away from the journey. Hang in there, work on your data and processes, and things will start to improve. Next topic, the project must consider staff and drivers. Algorithms, or generally speaking, a decision support tool needs certain skill sets for staff using the system. One of them is having an analytical view on what it shows. Management style might need to change to focus more on exceptions and KPIs instead of noise level. Screaming and shouting of clients or sales or production managers. This might also have an effect on the communication style you have with these parties. I already touched upon the changing interaction between logistics, sales and production. And this means that people responsible for these organizational functions might need to unlearn certain habits. What helps is transparency of goals, clear roles and responsibilities while balancing the power of those three functions. And enforcing a management style with shared objectives, focusing on the process. It's not about my customer, my plant, or my truck anymore. While focusing so much on systems and schedules, it is easy to overlook the people that are supposed to execute those schedules. Explain your drivers why you are doing this and what it is you aim for. Train them in the new processes according to the new business rules. And make sure they understand the objectives and try to identify potential issues early. Again, you don't want to find out on the day of go live. And when going on this journey, what can you expect? So dispatchers and planners roles typically grow in importance for the company. After around 6 months, you might find a certain turnover on staff initially working in dispatching. And when looking at that, remember what I said about skill sets. These guys just do not fit anymore. Roles associated with logistics can become a stepping stone for a management career. Driver qualification, especially illiteracy. You can expect that you will find out if a driver can't use the telematics device because he or she cannot read. And if he can't read, he will not drive where he's supposed to. And consider LOD and haulier union actions as well when going for this change. The key is to involve them. Centralization versus decentralization. There are pros and cons to each side, and sometimes companies swing constantly between those two. I can only tell you from my experience what successful customers have done. Successful customers made their business act as a network that shares orders, plants and trucks, that unifies product master data where technically possible, and that let their trucks go everywhere. Planning and dispatching organizations, successful customers centralize these tasks, meaning planning for a region must be centralized. Dispatch allocation does not happen at plant level, but rather in a regional, state, or even nationwide setup. Why? National centralization can help unlock saving potential on dispatcher and support headcount. It can improve process quality, but may create cultural conflicts in the business. Address driver LOD performance management locally or through a dedicated role. This means go out and talk to the people, and that means going where your people are. Last slide on centralization versus decentralization reporting. You want global KPIs and KPI performance management. Technology can help you overcome some of the centralization versus decentralization dilemmas. Use it. Examples for that are telephone and radio routing. And information availability. The same information should and can be made available to all logistics staff in the network. So you will have only one source of the truth. Staffing hours and hours of operations, there might be changes needed. as successful customers operate under the paradigm that there must always be a dispatcher available if trucks are on the road. And last but not least, try to align costs and revenue accounting for all parties in your network and link management incentives and reporting lines to desired logistics objectives and the way of working. You might say now, Jesus, Paul, that's an awful lot to consider when getting out of the comfort zone of manual planning and heading down the rabbit hole of digital transformation. The intention to make you aware of these points was that you avoid the biggest risk our clients are facing with such a project. Having added new technology to an old process will only equate to an expensive old process. This brings me to the end of my presentation. If I had to summarize all this into one sentence, I would use a quote from Agent Smith, another famous character from the Matrix movies. His line was, "Never send a human to do a machine's job." The guy here in this photo is not Agent Smith, but my colleague Carsten Horn. And instead of the Matrix, we recently sent him to a quarry and shot a 10-minute video called 5 Lessons Learned on the Road to Digital Transformation. It turned out to be an exciting, entertaining, and educational road movie with lots of noise, dirt, and action. Just scan the QR code and enjoy watching. Thank you very much.
Paul, thank you very much for that presentation. That's an awful lot to take on. The potential of digitizing AI in this logistics part of the process is enormous. Is there an optimum size of fleet for a company considering this kind of logistics solution? Is it only for very large fleets, or can smaller operations consider it?
Yeah, also it's for smaller operations interesting. In the full truckload world, there is an indication around, okay, something around 60 to 70 truck size fleet. Yeah, below that, it's probably not interesting because you can or you don't have the necessary complexity. So from 60 to 70, let's say, is from our experience the minimum number of fleet, which already is what a lot of, let's say, medium-sized company already have. And scalability up to, we are currently doing up to 5,000 daily in Europe in one instance. So this system scales rather largely.
And I guess that makes it well suited to the cement industry, especially we've got to remember that transportation is such a large portion of the cost. It's a low value commodity, and I know that now, especially with the CO2 reduction imperative, it makes it even more important to consider this kind of efficiency saving. But also, as you pointed out, it's also the resource, the drivers, and the shortage in Europe that we've experienced coming out of COVID, and that has really impacted the supply chain. So that makes it another very, very useful resource to have. In terms of where you're seeing it being picked up, is it mainly in Europe and North America, or are you seeing it all around the world, interest in this technology?
Yeah, it's all around the world, Thomas. Coming back to the points you made earlier, the whole solution is about not wasting resources, and resources are drivers and are trucks, and you waste a truck resource if you unnecessarily travel the truck empty. And of course, you also waste driver resources if you're not putting the driver in a position where he can deliver the maximum amounts of loads during his available shift. And this is a large point where this system benefits you in several ways. And Coming back to the previous point, so we have a large footprint in Europe and also in Asia and Australia, and smaller footprint in the US, but we are hoping to grow that, of course.
Yeah, I'm sure it's a perfect market for you there as well. So, well, thank you very much, Paul, for that presentation. The slides will come round, so if you want to, you'll be able to see this QR code on those when you receive them, if you haven't already. Great presentation, very useful, and thank you for your time today, Paul. That was great. So that's our third live presentation. We have one more presentation for you now. It's going to be a recording, which we've received at the last minute, but I think it's going to dovetail well with what we've just seen, and you might just catch a glimpse of Carsten Horn again. This is the Yard Road Automation and Logistics workshop from Holger Süß and Axians, Germany, and Carsten Horn from Inform. So I'll just play that for you now.
Hello everyone, and welcome to today's Logistics Tech Show. We only have 20 minutes, so let's get this webinar rolling. Based on our success of our previous webinar, Rivals or Allies, Yard and Road and Semi Logistics, we decided to take Logistics Tech Short to the shop floor. Instead of the usual slide-driven presentation, we will use this new format to dismantle logistics technology, look what's inside and what's in for you. In part one of our Yard and Road workshop, we will talk about automation. Let's welcome our two mechanics. On the yard man at the toolbox, Holger Süß of Axion. He just commissioned a logistics automation project for one of their customers in the aggregates business. And the roadman at the tire side, Carsten Horn. In his role at Inform, he optimizes the logistics performance of building materials producers around the world. My name is Dick Schlemper and I'm your moderator. Gentlemen, the board behind you is empty. We need to fill this with information. Are you ready? Okay, Carsten. Let's start with topic number one, automation. What is it? Please start and explain what automation in logistics means to you.
In general, automation is solving the problem once and then putting it on autopilot. In logistics, however, the problems are constantly changing and you need to solve them quickly before and you can then put them on autopilot. Take, for example, transport planning. If you have 60 trucks and 60 orders, the number of possible transport plans is 8 to the power of 81. So even if you're a big number nerd, it would take you ages to calculate them all and select the plan that promises lowest cost and highest service level. And this is where algorithms and AI come into the automated decision-making game. Because algorithms, they can do incredible complex, time-critical calculations with ease. And what's more, they can process a larger range of variables, resulting in better overall decision quality. Today, AI systems outperform legacy systems by means of speed, productivity, and financial performance.
Automation for me is less stupid work. Automation brings us in the position that the machines will take over the boring part and helps us to be focused on the core business and let us do more interesting jobs. The VSDR logistics system takes over the disposition of the trucks at the entrance, where the trucks can be weighted, during loading, and as well at the exit, where the second weighing can take place, and the necessary papers can be printed. With this, you have finally time for more important jobs and professional work. With the flexible interface technology, VS can communicate with any other third-party system, and the technical environment more reliable and consistent than humans could do. Also, processing data for reporting and workload with accumulated data is the strength of IT. Let us use automation for responsible, secure workflow to reach a high quality level in our daily business. Saying this, it also raises the customer satisfaction.
Thank you, gentlemen. We will round up each topic with our tooltip. And here comes tooltip number 1. Automation comes in different shapes and sizes, allowing you to unfold better processes, be it for inbound or outbound logistics. Okay, let's move on to topic number 2. The pros and cons. Automation doesn't come for free.
Sure, for the startup, we must calculate with an invest. However, Axions with focus on consulting and software solutions is independent of the hardware equipment and existing systems. This is one of the reasons why VS solution can be implemented so easily. Based on an intensive starting phase with a detailed specification and process analysis, workflows can be hardened. This brings an optimized human resource planning, higher efficiency, and a full utilization of the equipment. To invest in a full automation system brings a short return of investment. This can be optimized by a finance purchase, rental, lease agreements, or software as a service solutions. Cost control by using software as a service for temporary unused licenses is feasible. Flexible license models can be provided.
Okay, thank you. Awesome.
Restoring a classic car takes blood, sweat, and tears. And converting your old diesel car into an electric vehicle can be quite challenging too. And the same applies to logistics processes. They do not become automated overnight. And bolting shiny new technology onto old and rusty processes, well, that isn't the right approach, because old processes plus new technology will always lead to expensive old processes. Automation requires change at a deeper level, but when done properly, the benefits are huge. Our AI-powered transport planning software typically allows you to cut your fleet size by up to 30%, cut your logistics unit cost by up to 20%, and achieve a better on-time performance. Automation is like restoring a classic car. It increases the value of your asset, and it's fun to drive.
Thank you, gentlemen. So here's our tooltip number 2. Automation is the perfect tool to cut costs and inefficiencies. But as with any sharp tool, be careful and know how to use it. Okay, let's move on to topic number 3. Data and interfaces, the key driver for automation. How do you ensure smooth and safe data traffic between all parties and systems involved? Olga, your turn.
Well, in the long past, we found everywhere different interface standards and different data to connect to. No common standards were established on the third-party systems and on the hardware. General digitalization, cloud services, and the today way of work brings us all one step forward. Today, the easiest way to interface is using open APIs and web services. Interface technologies like REST, SOAP, and many more are decades implemented and standardized. The variety of interface standards used differently by any third-party system are well known and are handled easily and efficient since long term. Data structure and data safety are ensured in an experienced and professional implemented database architecture. Carsten, running interface solution makes the work also easier for you, or?
Absolutely. I like to compare it to a screw. Without standardized threads, a screw would be useless. With the latest interface technologies, we can easily bolt our software onto third-party systems. And this allows us to tighten the connection between yard and road. Here's an example. We use GPS data from the trucks to constantly update our transport plan. And any additional status information will help us to further fine-tune our calculations. And this is where your system comes into the game, because it allows us to tap information from various in-plant sources like timestamps from the gate kiosks, from the weighbridges, or from the loading stations. And your report app even allows us to tap delivery information from the customer side. Or in other words, don't let untapped data screw your automation goals.
Thank you, gentlemen. Let's summarize this all in our tooltip number 3. Use the right interfaces and storage strategy to get your automation project rolling. Okay, topic number 4 is clean data. A clean and clutter-free workshop is key to a productive working environment. I guess the same applies to data and automation projects. What are your key tips to avoid data mess? Carsten?
Automated decision-making is easy. Just shovel piles of data into one side of a computer and then collect the answers on the other side. And what if the answers are wrong? Well, stir the pile until the answers start looking right. No, sorry, but it isn't that easy. Algorithms cannot turn missing, incomplete, or wrong data into actionable decisions. Proper data cleaning is the foundation for the entire life cycle of an automation project. That sounds simple, but the daily grind of data entry is a tedious and error-prone activity. And many companies, they simply do not have the necessary processes in place. The true cost of bad data can be best described by the 1-10-100 rule. It costs $1 to prevent bad data entry, $10 to correct bad data, and $100 to fix a downstream problem created by bad data. And beware, touching up and polishing your data is a never-ending process.
Okay, Holger. Clean data is necessary, not only but especially for cloud services to reduce expenses. Every transaction, every storage, every calculation results in effort. To achieve clean data, a clear defined data service architecture and data structure is mandatory and upfront. With our long-term experience, a professional consultant can establish, therefore, a clear process definition for the necessary multiple layers. This result also big data is easily to handle with high performance, sustainable, and efficient. Data availability and data safety is important to consider, not only to be compliant with legal data protection rules. Using cloud services gives also benefit for you to help to identify customer needs and wishes better and to improve your customer satisfaction.
Thank you, gentlemen. So here comes tooltip number 4. As soon as you see dirt or dust on your data, clean it up. Take out the garbage before your processes start to smell. By the way, are needed to manage and run automated supply chains? Holger?
Automation makes the life more easy and simple for the user. Truck drivers are in the meanwhile familiar to use mobile phones all over the world. For everybody, digitalization came into reality in the last years, and everybody can perform a check-in at airports or use digital tickets for trains, concert halls, and so on. To use a full automated system with an experienced and easy user interface, the basic skills to interact with the today's world are enough. And this is also what the people want. Speed up processes, don't waste time while waiting for interaction. They want and can do a check-in, check-out, and hit the loading by themselves. And they have all information in their hands, the most current ones, and whenever they need it in the correct format. For example, a QR code for a successful check-in or the plant stuff. They can review the plant status on a web browser or mobile app in real time, or even review reports and statistics at any time, wherever they are.
Okay, thank you, Martin. We all know the old slogan, if it ain't broke, don't fix it. Many dispatchers are confused when new technology is implemented because they believe they have done a good job without automation and feel that their experience and skills are underrated by its introduction, especially when AI-powered tools take over a big part of their decisions. But quite the opposite is true. When planners are relieved of repetitive tasks, they will be free to focus their skills and experience on solving larger challenges, managing by exception and improving service levels. What we have seen at our customers over the past 25 years is that the roles of dispatcher and planner grow in importance. And logistics can become a stepping stone for a management career. So the slogan, if it ain't broke, don't fix it, should not become an excuse for inaction.
Thank you, gentlemen. And here's our tooltip number 5. Machines are great, but no machine is better than a human with a machine. All right. Just one more topic to go. Autonomous trucks. There's a lot of hype around this. Where are we right now and what impact will they have on logistics automation? Carsten, give us your update.
Well, first of all, truck driving is a lot more than holding a wheel. This is particularly true in the building materials industry. Take, for example, the driver of a ready-mix truck. Some say self-driving trucks are the solution to driver shortage. Well, everyone agrees that autonomous trucks are coming, but yet there's not much consensus as to when they will hit our roads. And these trucks won't be driverless initially. It'll take them many years before trucks are truly free of drivers. While truck drivers may see their status as king of the road challenged by AI, dispatchers have successfully been co-working with algorithms for decades. As I mentioned earlier, transport planning tools powered by AI may reduce your truck fleet size by up to 30%. Or in other words, that's 30% less driver seats to be filled, be it with humans or robots. Okay, Holger?
Yes, it will take a couple of years until they are here. However, autonomous trucks are maybe the best example for automation and reduction of human work. But what is the benefit of an autonomous truck when it has to wait for somebody for the last mile? Therefore, a yard automation system must be prepared already today. Tomorrow, when the first autonomous truck arrives in the plant, the human-machine interface only has to be extended by the machine-machine interface. The system identifies the truck at arrival and directs it to the correct loading station. Thanks to the pre-assigned delivery, the correct product and quantity gets loaded. The digital delivery load needs to be transferred on the truck and to the unloading site, including the estimated arrival time. And they are back on the road. Having these trucks also electrified, the CO2 reduction gives another plus. So we must today already think on how to charge the truck battery while loading the truck itself, to optimize the utilization as well.
Thank you, gentlemen. Here's our tooltip number 6 and the final one. There's still a long way to go on the road to autonomous trucking, but make sure you're in the driver's seat of change management. Okay, now it's time for our audience to make their hands dirty. If you have any questions, please type them into the question box in your GoToWebinar control group. We have already a few questions coming in, so let me see. Let's start with this one. Have you implemented an interface between Inform software and the BAS system? Well, you're the interface expert.
Yes, we have already realized together solutions for big companies where the data is exchanged in a secure way. Also, our competences match for a perfect combined customer-oriented consulting to bring yard and road together. Based on our long-term experience with Inform, we can realize a professional project workflow and data exchange easily for you.
Anything to add?
I couldn't have said it better.
Okay, fair enough. Okay, let's see, what else do we have? Here's a question for both of you. Is it possible to implement your solution in several steps for our company? Carsten, your thoughts?
Yes, our customers typically take a stepwise approach. We'll select a pilot region with a certain number of plants and trucks or a specific business line, be it aggregate, cement, or ready-mix. And whenever they are ready, we'll continue to roll out our software onto other regions or business lines.
Thank you. Holger, your answer?
Yes, the concept of the VS system is very modular and is built out of several most independent applications. This allows customers to prioritize their next digitalization steps. Some of our customers start with a smaller scope, like only implement automation at the plant entry and the plant exit. In a later step, the truck loading automation will be extended easily. With this approach, there is a better control of the invest in time and knowledge.
Okay, thank you, Holger. We are already way beyond our 20-minute cut-off time, but anyway, let's take one more question. And here's one more on Holger's BAS system. To review plant data on a mobile device, does my plant system need to be located in the cloud? That's the Holger.
Yes, the data can be accessible on a mobile device everywhere in the world. But no, the plant process, logic, and data can stay on premise. Only the necessary data for the overview needs to be transferred to a data center where the mobile device can access it. For this interface, of course, a secure connection is relevant and established.
Okay, thank you. Carsten, any famous last words from your side?
Whether it's cloud or on-premise, always start with customer experience and work your way backwards to technology.
That's a great line to conclude our workshop. Thank you, Carsten. Thank you, Holger. And thanks to our audience for joining us today. If your question hasn't been addressed, don't worry. We'll send you the answer by email. Date and time of our next Logistics Tech Short will be announced soon. That's all for now. See you next time.
Thank you very much. Their presentation from Inform and Axians to conclude our session today. That's the end of cemtech's live meetings for us this year. We'll be back in January. Look out for the schedule. We'll be sending it out to you shortly. We'll be starting on the 12th of January with maintenance, and I hope you will log back in then. In the meantime, thanks again to our panel, to Paul Flashkamp from Inform and Javier Garcia Sedano from Optimative, Christoph and Marcus from Kluber and Dalog. A fantastic session, a great one to end the year on. Thanks for all the questions, and many of them have been answered there. We are delighted to have concluded this year, not as we wanted. We thought we'd have more chance to meet in person, but that hasn't happened. So once it does, we will be first out to bring you together in person. But for now, thank you for supporting us. Do take a look at our website and the International Cement Review subscription. It's there if you like what we've been talking about in our webinars. Then you will absolutely want to read what we have in the magazine too. So to all our speakers and to everyone who has participated, thank you, and see you again shortly.